Okay, so Leetcode practice time. So two goals in this video. The first one is to find a solution and then put some code for this problem. And then the second one is to see how to solve this problem in a real interview. So let's get started. So remember, the first step is always to try to understand the problem and ask clarification questions if there's anything that is unclear to you, and then think about the edge cases. So let's first read through the problem. So it's called integer to English words. So convert a non-negative integer num to its English words representation. So for example, for the first one, 123, it is read as 123. And then the other one, for example 2, 12,345, etc. Okay, so the constraints, num is between 0 to 2 to the power 31 minus 1, which is within the range of a int 32 for the positive numbers. So I think there's not much about the solution. Actually, it is, so if this question is asked within a real interview, I think it's mostly looking at your coding ability, because there are a lot of edge cases you need to think about. So for example, like the hand, so okay, so it is like for example, under 20 there are 1 2 3 4 5 6 5 9 9 10, and 11 12 13 14, something like that. And above 20 there are, like, for example, 30 50 70, something like that. Yeah, I would say that's mostly about the coding part, but let's give it a try by doing some coding things. So I would first define some helper function. Let's say for the ones, what we are going to do. So for the ones, suppose we are given the int I, let's say int num, then we are going to switch the num as case 1 is equal to, we are going to return 1. Okay, so first letter should be capital, and then we copy paste it to be case 2 3 4 5 6 and 7 8 9. Okay, so 8 and 9. Okay, so this is a two digit, sorry, this is 1 digit. I was thinking about 1 digit, but I said 2 digit. So, and then 3 4 5 6 7 8, and this is 9. Okay, so that's it, and this one we just return an empty thing at the end. And the next one I would think about is under 20s. So under 20s, under 20. So if it is under 20, then I will see num as equal to this. I will switch the num. So 1 2 3 4. So this is 1 2 3 4. Okay, it's I line. So we switch the num again. It's about different cases. Should we put the 10 here? So if it's definitely let's say for the ones, I would just, first case is 10, I would say 12 20. Okay, so 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, and 20. Okay. The last one is 20, so this one will be 10, 11, 12. How to pronounce it? 12. Okay, 12, 13, 14. Is it 14 and 15, 16, 17, 18, 19, and then is 20. Should we actually put 20 here? Because if it's 20, I think we don't need to put 20 here. Instead, we define something else for it. So the next thing I would define is the tens. So it's the 10. So it's the tens. So regarding the tens, let's say, maybe I can say, so to match this one, let's say 2 digits. Not 2 digits, let's say just tens. Okay, so maybe this one we call it ones. Okay, then int num, and then you do another switch. Switch this time is all the like 20, 30, something like that, 40, 50, 60, 70, 80, and 90. Okay, this one is 20, 30, 40, 50, okay, 60, and 70, 90, sorry, 80 and 90. This is 80. Alright, so we have the tens, ones, and the 20, and those are defined. So let's get a something, another helper function sitting on top of that. Let's say, okay, so let's say how to say that. It's, let's say we define a helper function called we call it 2 digits. Then it's mostly about handling everything under 100. So it's going to be num like this. So first of all, this is 20. So if the num is smaller than, so if num is smaller than, if num is smaller than 10, then we simply return ones with the num. Okay, and then if num is smaller than 20, then we simply return the 20s under 20 for this num. Otherwise, it's larger than 20. We will need to compute the tens. So int tens is equal to num divided by 2, and then times 10. So this is the tens. So those are the tens. Okay, and then we are going to compute the ones. So this one, it would be num modular 10. Alright, so let's see. So because if ones is equal to 0, so we just need to return let's say 10. It's the same thing. So 10, let's say just second digit, maybe just tens, tens num. Okay, ones num. Okay, so if ones num is equal to this one is equal to 0, then we return tens, tens num. Otherwise, we need to say, okay, it's larger or equal to 20, and the ones are not 0. We would return tens, tens num plus a empty plus a space in the middle, and then we will call it the ones, and on top of the ones num. Okay, and then let's define the private, and let's define the 3 digits, which is a 100, the anything under 1000. So 3 digits. So this is int num. Okay. First of all, let's say define the hundreds num. It would be equal to num divided by 100 and then times 100. Alright, so just how many 100s are there? That's just fine. So, and then we would define the rest of the 2 digits. The rest, let's say rest is 2. Rest is equal to num modular 100. Okay. So there are several things we may need to think about. So if 100 num is equal to a 0, that means it is not more than 100. We just return 2 digits. 2 digits. Okay, rest. Okay. Otherwise, it means the hundreds num is larger than 0. If it's larger than 0, first of all, we need to see whether the rest is equal to 0. So if it's not, if it's equal to 0, we just need to return. So first of all, we call the ones on top of hundreds num plus equal to a space, and then it is 100. Okay, and otherwise it is actually so return the ones, how many hundreds are there, and then plus the 2 digits things. Okay, which is the rest. Okay, so we don't need this else here. Instead, it's just we can just pull out this expression. and then it's number 2 words. So we need to define, maybe there is trillion, right? Trillion, billion, something like that. So I don't know if there could be like several trillion. So 2 to the power of 31, yeah, so let's define the trillion things. So first of all, we will define the trillions is equal to num divided by, okay, this is, okay, thousand, million, billion, this is trillion, okay. So first of all, let's see like the max int 32, or what is that? So it is actually 100. This is 100, this is the million, this is the billion. So the int 32, okay, so it doesn't have trillion, so we just need to care about billion. So we just have the billion, we have the million, which is equal to num minus billion times the billion. Actually, so in the real code, you need to define this kind of constant to be, you need to have some constant defined for it. But here we just list it here. Just refer the exact number. So minus the billions, and then we divided by the millions, okay, and then the thousands. Okay, so the thousands. So the thousands would be nums divided by okay, so actually we could okay, so how to do that? Okay, so we could just do this. So we could just minus equal to the, so we minus all the billions here, because we want to make the expression to be more efficient. Then it is nums divided by the million, and then we are going to minus the billions, taking track of that, million times okay, so in the thousands, regarding the thousands, it's the num divided by the thousand. So okay, after the thousand, it is not, okay, minus the thousand times the thousand. Oop. So it's then the num only contains the number less than the thousand. Okay, so that's the thing. And one thing we need to think about as special case is, if it's equal to 0, then we just simply return 0 without doing much of the computation. So how to do that? So if okay, so how to say that? If it only contains a billion, so let's say we just have the RET as this one, and if billion is larger than 0, then we will have RET plus equal to how many billion? This would be 3 digits, and called on top of billion. Alright, so and then maybe a empty thing here, and then if the million is larger than 0, then RET plus equal to what is that, 3 digits, the million thing plus the million. Okay, so and if the 1000 is larger than 0, then RET plus equal to the 3 digit again on the thousands, plus equal to the 1000. Okay, so sure. Then if rest is larger than 0, the RET plus equal to the rest, which is the 3 digits, and then the num. Okay, this is num, and then finally we return RET dot. So the strap is going to exclude the things. Okay, exclude the leading and potentially leading and extra spaces there. So let's see. So I think, yeah. So we don't need have too much yeah. So usually for the testing, if it's not some question like this, we need to go through some test cases, explain how it works manually. But this one, since it has a lot of branches, so it is very hard to cover everything manually. So let's just run this code and use this platform to help us. So run the code, 2 digits, some typo here, let's fix it. If rest is, it's not the rest, it's actually the num. Okay, sure. So the compiler on line 50. Okay, so we need to return something empty. Alright, so RET plus equal to we need to initialize it. Okay, so it's except for this one, let's submit it. So for the wrong answer, okay, so we have typo here, it is actually 40. It's 40. Okay, it's my bad. Okay, now it's accepted. Cool. So I think regarding the test case setup, it's very hard, but it's very hard to mention what test case you want to set up, but definitely say something like for we are going to test all things like under 10, under 9, under 20, and hundreds, and also including things like the billion, million, thousand. So that will be, I would say that should be enough for it. Yeah, so just mention that we should set up those test cases to have good enough test coverage. But other than that, I think we should be good. So that's it for this coding question. So if you like it, please give me a thumb up, and I'll see you next time. Thanks for your time watching this video.